Physical quantities and measurement. Measurement of length. Importance of measurement. We often ask very common questions like, what is the length of this room? How long are you waiting? What is your age? Etc. Study of physics is based on measurement. In physics, we usually learn how to measure quantities that are involved in it. Among these quantities, some are length, mass, time, temperature, pressure, and electric current. Anything which is measurable is called a physical quantity. We measure each physical quantity in its own units by comparing it with a standard. Without measurement, we cannot make the correct judgment about length, area, volume, etc. An arbitrary estimate gives us a wrong information about the dimensions of an object. Example 1. Two lines XP and YQ are given below. Look at the two straight lines XP and YQ drawn alongside. Which of them is longer? You may guess that YQ appears to be shorter than XP, but when you measure with the help of a ruler, you find that both the lines are equal in length. Thus, we can say that in this case, length is the basic measurement and ruler is the tool needed to measure the length. Fact: in ancient Egypt, water clocks were used to measure time. A container is filled with water and the water is drained slowly. The amount of water dripping from one bowl filled with water to another marked the time passed. Example 2. Two glasses containing milk are given below. In the above figure, two glasses contain milk. It is difficult to guess which glass contains more milk. We can only tell it with the help of measurement. Some other examples. 1. A vegetable vendor sells vegetables, fruits, etc. by measuring their mass. 2. A carpenter measures the length and breadth of the wood before giving it the shape of a door. Think, what will happen if he does it without proper measurement? 3. You take the help of a clock to reach school on time. 4. A doctor checks the fever of the patient by measuring the body temperature. 5. A milkman measures the quantity, volume of milk before selling it. From the above examples, we see that measurement is an integral part of our daily life. In this chapter, we will learn to measure length, mass, time, and temperature. Need for accurate measurement. To know the correct mass, volume, and length of an object, we must measure these physical quantities accurately. We purchase milk by volume, cloth by length, floor tiles by area, timber wood by volume, and fruits and vegetables by mass. In the same way, each and every component of a machine should have high degree of accuracy of measurement. What would happen if each part of a machine has its own standard of measurement? Components of a machine are manufactured at different places. If each component is different in measurement, there will be a difficulty in assembling the machine. To remove all such difficulties, measurements are controlled very accurately. The water tap you bring from the market fits into any pipe of its measurement. This could not have been possible without a control on the accuracy of measurements. Expensive metals like gold, silver, and platinum are weighed extremely accurately. Often, errors occur while measuring, hence various methods are used to minimize and correct the errors. More the number of observations, less will be the possibility of errors. The error in measurement inside a laboratory can be minimized by taking average of measurements. The average can be given as average is equal to sum of observations divided by number of observations. Thus, Measurement can be defined as the comparison of an unknown quantity with a known standard quantity. Approximation in measurement. In our daily life, sometimes we need only approximate, near to accurate measurement. The approximate estimation is a quicker judgment about any measurement. Examples: 1. We add salt in vegetables by a quick judgment or approximation. 2. Painter paints the wall by mixing an approximate quantity of water. 3. We add sugar in a glass of milk by an approximate estimation. Hence, we can say that approximation is the rough idea about the measurement of a physical quantity. They are not accurate measurements, but quite near to the correct measurements. Units of measurement. Measurement requires the comparison of an unknown quantity with some known fixed quantity of the same kind. This known fixed quantity is called the unit. Each and every measurement consists of two parts. 1. A number called numerical value. 2. A symbol or alphabet that denotes the unit associated with it. Examples: 1. When we say quantity of tomato is 5 kilograms, then 5 is the numerical value and kilogram is the unit of mass. 2. If the amount of milk is 4 liter, then 4 is the numerical value and liter is the unit of volume. Nowadays, to measure the length, we use the unit meter. In ancient times, the length was measured by comparing it with the length of the body parts. A cubit was the unit of length. 1 cubit was the length between tip of the fingers and the elbow. Similarly, a handspan was the length from the tip of the thumb to the tip of the little finger. These methods were inaccurate because the size of fingers differ from person to person. In the same way, one cannot use a glass to measure the exact volume of the liquid. Such a system of measurement was not correct. To express the measurement, we should know: 1. A unit in which the quantity is measured. 2. The magnitude of the numerical value associated with it. Activity: to measure the length using handspan. Use your handspan to measure the length of the table. Now, ask your friend to use his handspan to measure the length. You will notice that there is a difference between the two measurements. Therefore, for reliable and accurate measurement, we need the standard units of measurement. Standard unit. To overcome variations in the measurement, the need of a system of standard units was felt. A unit which is acceptable by a majority of people as a basic unit of measurement is called standard unit. The internationally accepted system of units is called SI, Standard International Units. This system of units was adopted in October 1960 in 12th International General Conference on Weights and Measures. It was agreed that the unit of physical quantity should have following characteristics. 1. The unit should have a convenient size. 2. Its value should not change with respect to place and time. 3. The system of units should be acceptable everywhere. 4. It should be well defined. Fundamental units of SI system. The fundamental units do not depend on any other units. They have their own values. The SI system has 7 fundamental units which are given below. Table: the base quantities of the SI system of units. Quantity, unit, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Direct measurement of length. To measure the length, we need some measuring devices. For example, a measuring tape is used by a tailor. A metallic meter rod is used by a cloth merchant. A scale is used by you to measure the length of lines and figures and to draw lines of the given lengths. Normally, we use a meter scale or half-meter scale for measuring the length. The scale is calibrated in centimeters and millimeters. Suppose we want to measure the length of a rod. The 0 mark on the scale is set to coincide with one end of the rod as shown in the figure. The reading on the other end gives the length of the rod. Activity: to measure the length of a line. Place a scale along the line AB such that 0 on the scale coincides with point A. Note down the reading on the scale which coincides with point B. This reading gives you length of the line AB. To make accurate measurement, we require a proper measuring device. The choice of the measuring device depends upon the following. 1. The size of the object to be measured. 2. The shape of the object to be measured. 3. The degree of accuracy required. Vernier calipers and screw gauze are two such instruments which are used to measure very